Physics. In that, the topic we are going to discuss today is complex integrations. Complex integrations using residue theorem. So, integral C f of z dz, where z is a complex function, and C is a contour. So C is such that z minus x plus iy is equal to r, where x is called as center of the circle. We are taking a circle like this of radius r, here x comma y, like this. By default we are taking anti-clockwise direction, So example, z minus I plus 5i, 1 plus I is equal to 5, which means center of that circle is 1 minus 1 and radius is equal to 5. Then B, C says that z minus 2 is equal to 5. Here center is equal to 2, 0 and radius is equal to 5. And C says that z minus I is equal to 3. So center is equal to 0, 1 and radius is equal to 3. So if you are taking a contour of f of z dz is equal to, so here we are taking a contour as C, such that z minus x plus iy is equal to r. Check whether the points lies outside or inside. Let z is equal to a is outside the contour, no need to take the point outside. In that case residue is equal to 0. Here let z is equal to BC is inside, then residue is equal to 2 pi I. 2 pi I into summation of r. The question comes, how to check the singular points are inside or outside. We are going to study that. First question, in a contour C of z minus 2 is equal to 3. Z is given as I, 2I. Solution, contour z minus 2 is equal to 3. So z is equal to I point. We need to check whether it is inside or outside. Then I minus 2 is equal to under root of 1 plus 4, that is equal to root 5 is less than 3. And z is equal to 2I is equal to 2I minus 2 is equal to root of 4 plus 4 is equal to root 8 is less than 3. So these points lie inside, so we can take these points. So second question, contour z is equal to 3. Check the points z is equal to I for I. Solution, contour z is equal to 3. So modulus of I is equal to 1 less than 3. So we can take it. And second, for z is equal to 4, is modulus of 4i is equal to 4 greater than 3. We can't take this point. Third question, contour z plus 1 minus I is equal to 2. Solution, where z is equal to, checking points is z is equal to I, 2I minus 2. So first at z is equal to I plus 1 minus I is equal to 1 less than 2. At z is equal to 2i plus 1 minus I is equal to root 2 less than 2. So we can take this, we can take this. At z is equal to minus 2 minus 1 minus I is equal to root 2 is less than 2. So we can take this. So we can take all these points. Next, C of x square plus y square is equal to 9. Only given, no z condition. So here z is equal to 1 plus I. So here we got x is equal to 1 and y is equal to 1. Therefore 1 plus 1 is equal to 2 less than 9. So 1 plus I is inside. Now check z is equal to I minus 3i. This is A, this is B. Solution: x is equal to 1. From z is equal to 1 minus 3i. From that we got x coordinate as 1, y coordinate as minus 3. So putting that in contour, x square plus y square is equal to 1 plus 9 is equal to 10 greater than 9. Therefore 1 minus 3i lies outside the contour. Next question: closed integral e raised to z plus 1 by z dz, where contour is given as z is equal to 1. So 0 less than 1. So where z is given as 0. Solution: 0 is less than 1. So 0 is inside. Therefore singular point is equal to 0, and to find the residue of f of z is equal to 0 is equal to e raised to z plus 1 by 1 at z is equal to 0, that is equal to 2. Next question: integral e raised to 2z divided by z plus pi I. Evaluate at z minus 1 is equal to 4 and b z minus 2 plus modulus of z plus 2 is equal to 0. Solution: z plus pi I is equal to 0, which means z is equal to minus pi I. So a minus pi I minus 1 is equal to root of pi square plus 1, that is equal to root of 10, which is less than 4. So e raised to 2z divided by 1 at minus pi I is equal to e raised to minus 2 pi I is equal to 1. Therefore closed integral e raised to 2z divided by z plus pi I is equal to 2 pi I. Then b modulus of minus pi I minus 2 plus modulus of minus pi I plus 2, that is root of pi square plus 4 plus root of pi square plus 4 is equal to 2 root 70, which is greater than 6. Therefore closed integral e raised to 2z divided by z plus pi I is equal to 0, because point lies outside. Therefore residue is equal to 0. So integral 6th question: integral tan z plus sec z divided by z dz. Contour is defined as modulus of z is equal to 1. So tan z plus sec z divided by 1 at z is equal to 0 is equal to 0. Therefore, closed integral f of z dz is equal to 2 pi I. Next question. Closed integral z square minus 3z minus I divided by z minus 2I into dz. Contour is modulus of z is equal to 3. So solution. Z minus 2I is equal to 0 means z is equal to 2I. So modulus of 2I is equal to 2 less than 3. So z square minus 3z minus I by 1 at 2I is equal to 2I square minus 3 into 2I minus I, which is equal to minus 4 minus 7I. So closed integral z square minus 3z minus I is equal to 2 pi I into minus 4 minus 7I, which is equal to minus 8 pi I plus 14 pi, that is equal to 14 pi minus 8 pi I. Eighth question. Closed integral sin z divided by 4z minus pi, where contour is given as z is equal to 1. So when denominator is equating to 0, we got 4z minus pi is equal to 0, which means 4z is equal to pi, z is equal to pi by 4, and pi by 4 is less than 1. So sin z, point lies inside, so sin z divided by 4 at pi by 4 is equal to 1 by 4 root 2. So a closed integral sin z divided by 4 z minus pi, residue equal to 2 pi I into 1 by 4 root 2, that is equal to pi I divided by 2 root 2. Ninth question. Closed integral 2z cube plus 3z plus 5 divided by z minus 2, where contour is z is equal to 3. So when denominator is equating to 0, we got z is equal to 2. So 2z cube plus 3z plus 5 at z is equal to 2. 2 into 8 plus 4 plus 5, that is equal to 25. So closed integral f of z dz is equal to 50 pi I. Next question. Closed integral z plus 1 divided by z square minus 9 dz. C is equal to contour z minus 3 is equal to 1, z square is equal to 9. Therefore z is equal to plus 1 minus 3. So z plus 1 divided by 2z at 0 is equal to 1 by 0 is equal to infinity. This 3 minus 3 is equal to 0 less than 1. Minus 3 is equal to 6 less than 1. So z plus 1 divided by 2z at 6 is equal to 5 by 12. So integral, closed integral f of z dz is equal to 2 pi I into 5 by 12 is equal to 5 pi I by 6. Eleventh question, closed integral z square plus 1 divided by z square into z minus 2 dz. Contour region is given as z is equal to 1. So when denominator is equating to 0, singular points z is equal to 0 and z is equal to 2. So limit z tends to 0, d by dz z square plus 1 divided by z square into z minus 2 z square, that is equal to z minus 2 into 2z minus z square plus 1 divided by z minus 2 whole square. So this is equal to 2z square minus 4z minus z square plus 1 divided by z minus 2 whole square. So this is equal to z square minus 4z plus 1 divided by z minus 2 whole square. So we got z minus 2 whole square divided by z minus 2 whole square, which is equal to 1. So in the closed integral f of z dz is equal to 2 pi I. So limit z tends to 0, z square plus 1 divided by z square is equal to 0. Then 12th question, closed integral cos square z divided by z plus pi by 2 whole square dz. So contour at z is equal to 2. So z is equal to minus pi by 2, where pi by 2 is less than 2. So limit z tends to minus pi by 2 d by dz cos square z dz. So that means 2 cos pi by 2 is equal to 0. So closed integral cos square z is equal to 0. Thirteenth question, closed integral log of z plus I divided by z into z minus 1 whole square, contour z minus 5 by 2 is equal to 2. So that is 5 by 2 is greater than 2. So limit z tends to 1, dy dz log of z plus I whole divided by z is equal to z into 1 by z plus I minus log of z plus I whole divided by z square is equal to 1 by 1 plus I. So closed integral f of z dz is equal to 2 pi I into 1 by 1 plus I. 14th question. Closed integral e raised to I z cos z divided by z minus pi whole square. So that is z is equal to pi is less than 4. So limit z tends to pi d by dz e raised to I z cos z. So that is e raised to I z minus sin z plus cos z e raised to I z into I, that is equal to minus I e raised to I z. So closed integral e raised to I z cos z is equal to 2 pi I minus I e raised to I z. It is equal to 2 pi I minus now into 2 pi I e raised to I z. Question. Closed integral 1 by 2z square plus 5z minus 3 dz contour x square plus 4y square is equal to 60. So this is 2z square into z plus 3 minus z plus 3 is equal to 0. That is z plus 3 into 2z minus 1 is equal to 0. So z is equal to minus 3 and z is equal to half. Modulus of z is equal to 4. So z is equal to minus 3. That is modulus of minus 3 is equal to 3 less than 4 inside. Z is equal to half is less than 4. So this point is also inside. So we can apply numerator by derivative of denominator formula here. So 1 by 4z plus 5 is equal to limit z tends to minus 3. 1 by 4z plus 5 is equal to 1 by 4 into minus 3 plus 5 is equal to minus 1 by 7. And in the next case, limit z tends to 1 by 2, 1 by 4z plus 5 is equal to 1 by 4 into 1 by 2 plus 5 is equal to 1 by 7. So closed integral f of z dz totally is summation of residues is equal to 0. Therefore 2 pi I into 0 is equal to 0. Next question. Closed integral e raised to z divided by z minus 1 whole square into z square plus 4 dz. So here contour is given as modulus of z is equal to 2. So solution is the singular points are at z is equal to 1 and z square is equal to minus 4. So modulus of 1 is less than 2, which is inside, and z is equal to plus or minus 2y. So residue of f of 2 z is equal to 1 is equal to limit z tends to 1 d by dz z minus 1 whole square e raised to z divided by z minus 1 whole square z square plus 4, that is equal to z square plus 4 into e raised to z minus e raised to z divided by z square plus 4 whole square is equal to e raised to z square plus 4 e raised to z minus 2 is e raised to z divided by z square plus 4 whole square. At z is equal to z is equal to 1, e plus 4e minus 2e divided by 25, that is equal to 3e by 25. Then residue at f of z is equal to 2i is equal to limit z tends to 2i z minus 2i into e raised to z divided by z minus 1 whole square into z plus 2i into z minus 2i. So this is equal to e raised to 2i divided by 2i minus 1 whole raised to whole square into 4i, which is equal to e raised to 2i divided by 20i. Then residue at f z is equal to minus 2i is equal to limit z tends to minus 2i e raised to z divided by z minus 1 whole square into z minus 2i is equal to e raised to minus 2i divided by minus 2i minus 1 whole square minus 4i is equal to e raised to minus 2i divided by minus of 1 plus 2i whole square minus 4i, that is equal to e raised to minus 2i divided by minus of 1 plus 4 minus 4i equal to e raised to minus 2i divided by 20i. So summation of this residue into 2 pi I, we got 2 pi I into 3 divided by 25 or first of all can take sum of the residues is equal to 3 by 25 plus e raised to 2i by 20i plus e raised to minus 2i by 20i. So 3 by 25 plus 1 by 20i into 1. So we got 3 by 25 plus 1 by 20i. So integral f of z dz is equal to 2 pi I into 3 by 25 plus 1 by 28. So these are the questions. The complex integration using residue theorem. In the next class, we will study complex integration along a curve and along a straight line.